Now that we've talked a lot about integration by substitution, we can talk about the integrals of tangent and cotangent. So, because those are going to be done by substitution. So let's go ahead and do this, the integral of tangent of x dx. So what we want to do is convert that to sine and cosine. So remember, tangent is sine divided by cosine. Okay, so now we want to do this by substitution. So remember, when you do a substitution, you want to look for a function and a constant multiple of its derivative, something like that. So the right substitution here is u equals cosine of x. So then du is negative sine of x dx. Okay. So if you try u equals sine of x, you can try that. There's no harm in it, but you'll see pretty quickly it's not going to get you anywhere, because then du would be cosine x dx, and then you don't really have those together the way you want them to be. So that's not going to work out. So anyway, let's go ahead and rewrite this integral just real quick. So let's put the dx on the sign. So this is going to be sine of x dx, okay? And then cosine x is still on the bottom. So now du is negative sine of x dx, right? So we don't exactly have that. We have just sine of x dx. So if du is negative sine x dx, there's a few different ways to think about that. What we could do is let's just divide this whole thing by -1. Okay, so we can divide the whole thing by -1. So then if you divide by -1, that's the same thing as multiplying by -1. So then negative du equals positive sine of x dx. Okay, that's one way to think about it. There's a few others, and they are mentioned in some of the earlier videos where we talked about integration by substitution. So if you want to see some of those, go ahead and check out the website or on the YouTube channel. They're all on there. So anyway, sine of x dx, that's exactly equal to negative du. And then on the bottom here we have cosine of x, which is exactly u. So then if we continue with that, so now we have that substitution made. So this is going to be the integral of negative du over u. Okay. So now let's rewrite that as negative 1 over u du. Okay. So let's pull out the negative also. Probably should have done that there. So that's negative integral of 1 over u du. And remember, if you want to integrate 1 over u, what's that going to be? So negative sign's still there, but now this is going to be natural log of the absolute value of u. Okay, so be careful about that. Okay, so, and then plus c, because it's indefinite, right? So now we have to go back to x, because remember, we're talking about integrating tangent of x, so we have to go back to x, can't just leave it with u. So u was the cosine of x, okay? So then this is going to equal negative natural log of absolute value of cosine of x plus c, okay? So that's pretty much it there for the integral of tangent. Now you might have seen this written in a different form, and the reason is this minus sign can be brought inside the natural log. Okay, so we can say this is the answer here, or you might have seen natural log of the absolute value of secant of x plus c. So let's see why that's true. So if we continue with this, remember the minus sign, so remember that rule about natural logs, negative natural log of a thing, or well, let's say more generally, r times the natural log of a equals natural log of a to the r, right, like that. So negative natural log of a thing equals natural log of a to the -1, which is the same thing as natural log of 1 over a, right? So even though we have absolute values here, it's the same thing. So this is going to be natural log of, let's write it like this, absolute value of cosine of x to the -1. Okay, so that's what's going on there, and then plus c. Okay. So absolute value of cosine of x to the -1, so that's going to be the same thing as, let's come up here, and let's maybe get rid of these. So that's going to be natural log of, let me show all the little details in between here. So that's going to be 1 over the absolute value of cosine of x plus c, right? So we're taking the natural log of this mess here. Now 1 is just a positive number, so 1 and the absolute value of 1 are the same thing. So we can put absolute values on there, not change anything. Now if we want to come back up here, so I'm just going to work up. So that's going to be the same thing as natural log of absolute value of that whole thing. Okay. So absolute value of the thing divided by absolute value of another thing is just absolute value of the division, like that. And then remember, 1 over cosine of x, that is the secant of x. So then this just equals natural log of absolute value of secant of x. And then plus c. Okay, so that's where this comes from here. All right, so that's the formula for the integral of tangent. So integral of tangent of x dx equals, you could say this negative natural log absolute value of cosine of x plus c, or you could say natural log of the absolute value of secant of x plus c, pretty much because 1 over cosine is the same thing as a secant, and because of that rule for natural logs, or just logs in general. you can bring the factors up as powers. So that's a pre-calc thing there. Anyway, that's it for the integral of tangent. Now let's talk about the integral of cotangent, which is actually going to be a little bit simpler because we don't have those crazy minus signs to worry about. But it's going to be pretty much done the exact same way, just with a different substitution. Okay, so integral of, oops, we have to change that to cotangent now. So integral of cotangent of x dx equals, so again, just change to sine and cosine. So cotangent is cosine over sine. Okay, so now we can make a similar substitution. Now we're still gonna let u be the bottom thing, so let u be sine of x, and then let du, or well not let, but du is just gonna have to be cosine of x dx. Okay, so then what do we have here? Well, sine of x on the bottom, that is u, right? And then this cosine of x dx, that just becomes du. So then this whole integral, so the dx is off here off to the side, but it's the same thing as sticking it up on the top, so nothing to worry about there. So this is just the same thing as du over u, okay, integrating that. Or we could just write that as 1 over u du, integral of that. So then that's natural log of the absolute value of u plus c. But remember, we have to go back to x, so this is the natural log of the absolute value of sine of x plus c. And that's really it for the cotangent, so there's no minus signs to worry about, no crazy tricks or anything like that. So if you integrate cotangent of x dx, this shows you why you're going to get natural log of absolute value of sine of x plus c. So those are the integral formulas for the tangent and cotangent functions.